Hello friends, welcome to our channel. In this lecture, I would like to explain another important concept that is related to the columns. So, introduction part. So, generally, what is column? A vertical member whose effective length effective length is greater than 3 times of least lateral dimensions which carries compressive loads is called as column. Means a vertical member. So any vertical member whose effective length is greater than 3 times of least lateral dimensions. So generally you can remember like this. Effective length is denoted with LE by D. That one will be equal to greater than 3. Means that is LE. Effective length is denoted with LE by D. D is the least lateral dimensions. So what is the meaning here least lateral dimensions? For example, if you see here, this is a square column of some 200 by 200 mm. So at that time the dimensions here will be same. So you can take down dimensions at D here will be 200 only. So if it will be rectangular means like this, if it will be rectangular of some different dimensions like this one will be some 200 mm and this one will be some 300 mm. At that time your D will be this one. Why? Because least lateral dimensions out of these two, one will be 200, another will be 300. At that time you can consider this least lateral dimension as 200. So there will be circular columns also. So for circular columns there will be only diameter. So like some 300 mm. At that time you can consider just whatever the diameter which is given in for that circular column. So if you observe means effective length to its least lateral dimension greater than 3. So whatever the effective length given and divided with least lateral. For example, square one you can take down 200 around, and for rectangular one out of these two whichever is less, that is 200, that is least lateral dimension. For circular one you can take down directly 300. So if you take that ratio and it will be greater than 3 means that comes under the column. So sometimes if it will be less than 3 means which comes under the pedestal, means effective length to its least lateral dimension is greater than 3 means column and less than 3 means pedestal. Pedestal means any member which is less than 3 means that is like statue also you can consider as one of the pedestal. Okay, then at the same time, so generally in the trusses we are seeing that so inclined members. So for example, if you assume this is a truss, we can see that in the trusses there will be inclined members like this. So these are called as struts. So in the frames there will be only vertical members which is called as columns. So that is the difference between the inclined members and vertical members. So vertical members are considered as the columns, inclined members are considered as the struts. So what is this purpose of the column? So already we people know that for example, so this is a column, you can assume this. So the column carry the loads of the beams and again followed by slabs. Okay, so this is the column, so this is the beam and this is the slab, and here generally at the bottom of the column there will be footings. So just I am roughly mentioning the detailing here. So here the column is a vertical member which transfer the loads from the both beams and slabs to the foundation. So the column is a member that transfer the loads, loads from the beam slabs to the foundation. Okay, and again you remember one more point here. So there will be, based on the slenderness ratio, based on slenderness ratio, there will be short columns, short columns and long columns, long columns. So what is short column and what is long column? Here the ratio of effective length to its least lateral dimensions is less than 12. So whatever the effective length is given, you can take down here, and again dimensions, whatever the dimensions. For example, so already I told you for circular one it will be given only one dia, which is 300 mm, 400 mm, like that. You can take that one as it is. For square one, both are same, 200 by 200, 300 by 300. You can take any one. But for rectangular, there you can consider least lateral dimension. Sometimes you can check down LEX by D along the 300 side and LEY by B along the 600 side also. I will explain you that point according to the IS while explaining the problems. Up to here you please remember, effective length to its least lateral dimension is less than 12. If its ratio is less than 12, then the design comes under the short columns, and effective length to its least lateral dimensions is greater than 12, that columns will comes under the long columns. So this is the important ratio what we have to remember always. So this is the important condition. So once again I am repeating the two values. So generally effective length to its least lateral dimension is greater than 3, that comes under the column, and it will be less than 3, which comes under the pedestal. At the same time, so there will be short columns and long columns. If its effective length to its least lateral dimension is less than 12, which comes under the short columns, and again effective length to its least lateral dimension is greater than 12, that comes under the long columns. So short columns are generally fails by crushing, so which is pure compression failure, and these long columns are failed by buckling. Buckling, long columns are failed by buckling. Then there will be types of column, different types of columns. So tied column and spiral column, spiral column, again composite columns, composite column. So what is a tied column? So if the main longitudinal bars, so I am talking about the tied columns, if the main longitudinal bars of the column are confined with closely spaced lateral ties. So I will show you here. For example, you take any circular square column. So there will be diabars like this. So these are called ties. So these are called the ties. So this is the ties. So for example, if you see in the form of the section, cross section, so I am showing about the diabars. So same line. So ties are the these lines. So these are the ties. So I am just showing the rough cross section of the circular columns, only the diabars and the ties. For example, in the beams, so we used the stirrups, but in the columns we say it as the lateral ties. Okay, you just remember that one. So which is called tied column. And what about the spiral column? For example, if you take any circular columns. So for circular columns, if you see the based on the diabars, if you see any elevations like this means, so here you will get the diabars in the form of like this. So there will be like this. So which is in the form of the spring. So that is in the form of spiral. So therefore we are called spiral column. I am showing rough diagram here. So this is spiral column. And what about the composite columns? So composite columns are in the form of structural steel sections. Structural steel sections. So which is in the form of without any longitudinal bars like I section. So some sections will be there. So those are comes under the composite column. Then, so I told you here effective length. What is the meaning effective length? Effective length is the distance between the point of zero bending moments of a buckled column. So already we people know in the beams generally we used to take center to center distance and clear span plus distance whichever is less. But in the column, whenever we used to solve the problems according to IS 456, which was in table number 28 in IS 456. So there you will have some conditions based on the effective length. Based on that condition only, you use it to consider the effective length for the particular column. Okay, based on the restrained conditions and unrestrained conditions. Then there will be some formulas which will be very useful to solve the design here. So generally one problem, so load carrying capacity for axial loaded columns. So there will be one formula which was in your code book also. This formula will be very useful. It is better to remember. That is PU equal to 0.4 FCK AC plus 0.67 F5 AS. So what about this FCK? Already we people know that is characteristic compressive strength of concrete. If M20 grade is given, take down 20 Newton per mm square. Similarly, Fi is the yield stress, and here AC is the area of concrete, and AC is the area of steel. Okay, I will tell you how to apply this formula. Based on this formula, how can you find the axial loaded column or area of the steel, all the things one by one. So up to here, and one more point what you have to know down means minimum eccentricity formula will be there. The formula will be E minimum will be equal to L by 500 plus lateral dimension by 30, which is subjected to a minimum of 20 mm. For example, after where L is here unsupported length. So lateral dimension means, for example, if it will be square means you can take down 200 around. For rectangular you can calculate in the x axis wise and y axis wise. Then you will get eccentricity minimum in x direction and y direction for the rectangular column, some 200 by 300 around. And if you calculate this one, you will get 18 like that means you can consider minimum 20 mm. For example, if you will get some 22 like that means you can consider eccentricity minimum 22 only. So based on that, whether you have to confirm this column comes under the eccentrically loaded column or axially loaded column. Okay. So this is the introduction part. While solving the problems, we will see some more introduction points which important concepts which was given in our IS 456.